So we're the sort of OGs of blockchain for impact.
Okay.
Since like 2013.
Nice.
I think I almost came up with the term blockchain for impact.
Oh, wow.
Like this video that you're watching here is from 2017.
Okay.
And I was talking about blockchain and AI. And we started doing our first POCs in 2015.
Really?
Using the Ripple blockchain.
Okay.
And then moved to Ethereum when Ethereum launched, and realized it wasn't going to be fit for purpose because this is very much a data platform. And so then ended up building our own layer 1 blockchain,
Really?
Which is Cosmos based.
Oh, okay.
Yeah. And so Internet of Impacts is a meta structure. So that you have networks of networks, so Internet of blockchains, as well as connected databases and all these different things that we can connect, but that are within Web3 that are purposed for or used for impacts. So even a financial inclusion like parametric insurance is impact.
Yeah.
And so it's a broad umbrella of enabling services like a parametric insurance provider to understand how they can actually have an impact, and then bringing it into the construct that impacts happen in a time sequence kind of way, and that there's a theory of change that happens. So there's a baseline, and then something happens and something happens. And so why we need the Internet of Impacts as opposed to the Internet of www is that you can hold records of the state of the world in the blockchain state space, and then it gets updated over time. And so now you've got, firstly, a verifiable record, like a fossil record. And then you can use that for measurement, for reporting, for verification. So DMRV, measurement, reporting, verification. And you can use it then for the measurement, reporting, verification for certification. So you can say, okay, because we've measured, reported, and verified it, we can certify that, for instance, carbon emissions were reduced. And then because this is in the construct of an outcomes framework where you have theory of change and you have units of measurement, you can then generate the units of measurement as, we call them impact tokens, but that's a broad class of 1155 standard tokens that are like carbon credits or internet connectivity credits or whatever.
It's super interesting. I mean, it's just like
yeah.
So I mean, this could be just like thinking out loud, right? So for the time being, SAP or so, all these major legacy system providers, it's not too easy to really have this enhancement of tracking what has been really done also on supplier side, right?
Yeah.
So companies having the challenge to really see and following what was really accomplished.
Yeah.
So this could be quite useful.
It's exactly the kind of thing it's used for. So why digital twins? So when we talk about digital twins, it's not a 3D digital twin. It's a cognitive digital twin. Okay, so a system has got different entities in it. Simplistically, it's like an organization, a project, and a device, for instance. I mean, simplistically, that graph of entities and the relationships between them is super important for understanding the change that's happening, and also for verifying the change. Because if you're just looking at one point, you may get, so you could arrive at my door and say, I ran all the way here to deliver this to you. I know that you're delivering it to me, but I didn't know that you ran here. You could have taken an Uber around the corner. And so how you get here and the context, the context is super important. So once you establish that context, now you can start, and each of the entities has a digital identifier. So I was deeply involved in the whole development of DIDs and verifiable claims, verifiable credentials, with rebooting the Web of Trust and W3C and all that. So, and then also developing a new DID method for interchain. So it's a method that resolves all DIDs on-chain. So you'll always be guaranteed that if you follow that, it's going to take you to an on-chain entity, which is the digital twin representation. So then that enables us to create these entities that have got governance in terms of all the cryptographic controls. You can have groups, DAOs, etc., built into the entity. I can explain to you how it works. And then you've got linked resources, like any resource. It can be a database, it can be verifiable credentials, etc. So you can now verify the identity of that entity, including an AI, for instance. Super important. You can verify that it is this AI, as long as it can cryptographically sign and prove that it is the service. Okay, and then you have services. So basically any web service can be plugged in, including an LLM, including anything, any web service, any microservice, whatever you like. You have executable rights, which are object capabilities that can be invoked in object capability systems. So an object capability is the opposite of an access control list. So most computer security is based on ACLs. So you got a central list of who's allowed to do what, different roles and so on. Super dangerous because you give somebody a role,
exactly.
and then especially in AI, the example I use is let's say you employ an AI agent to help you clean up your database, get rid of duplicate records. So you give it an ACL access to your database with admin rights, and not because it's nefarious, but just because it goes, to clean it up, why don't I delete all the records?
Could happen, right?
Yeah, and it's logical, because we didn't say, okay, only duplicate records, keep the other ones, don't delete everything, And so that's a really silly example, but it becomes quite complex to run these things if we haven't understood all of the possible permutations of what can happen. And so object capability is super important, and they're executable rights. So for instance, the right to mint a carbon credit if you are the owner of the rights of the NFT that has the rights. So we created an NFT digital twin of this and its impact producing system. And then if you own the NFT, you have the rights when the carbon emission reductions are certified to then mint the NFT carbon credits. So it's self-certification and self-issuance. So that's sort of at the blockchain layer. And then we've got a data infrastructure with federated databases with end-to-end encryption. So each entity has a room that's fully encrypted, and it gets replicated across a federation of servers. And you can set up your own federation. You can make it geo-fenced, you can make it within your organization or whatever. It's completely decentralized. What's interesting thing about that is that different organizations can use this, putting their data in, and they can share the data selectively across the supply chain. Yeah. So now you don't have the data silo issue because you don't have to tap into an enterprise database. What they do is they take the data from the enterprise database, they take the relevant bits, de-identified and so on, they fuse it into verifiable claims into a data graph, and they publish it into their room, end-to-end encrypted, and then have got fine-grained access controls to whoever they want to give access to the data.
Well, what about the, let's say, execution speed limitations in this sense?
There's not really an execution speed limitation. So think of it as, so if you're using a node or a server, basically, which is a node in the federation.
That's all it was.
Then that's a server you will use to write and to read. So your data is immediately available. It propagates to the other federated servers as quickly as it can, so it's eventually consistent across all the servers. But as long as you're relying on the primary in and out, you're going to get, you configure it as fast as you like. It's the database. Yeah. And then on top of that, and just the other things that the digital twin has is linked claims. So you've got a formalized way based on protocols, right, and data schemas and so on, what data comes in. And then we've got a claims processing capability where when you submit a claim, you can get a payment. When the claim gets evaluated, you can get a payment if it is evaluated approved, or even if it's evaluated rejected. There's different differential payments. And the evaluator, the evaluation service, gets paid automatically. All done, on-chain, distributed, boom, done. In any cryptocurrency that you like. USDC, etc. Yeah. And then that can be used to trigger other things, such as outcome payments on a bond. So we've got this bonding mechanism, is bonding curves. We developed an innovation called risk-adjusted bonding, which changes the shape of the curve, essentially, the coefficient on the curve, based on an oracle input, which is an alpha value between 0 and 1, which is predicting whether the outcome will be achieved or not. Okay, so think of a bond. Okay, so a bond is like a loan that you give somebody, and there's a coupon on that. So you say, all right, I'm going to give you $100,000, or you're going to give me $100,000, and I'm going to pay you back $120,000. That's a typical bond. Why $20,000 coupon? Well, because you're going to say, well, there's some risk and whatever, and I want some profit. Okay, the problem is that a lot of the things that get financed, you don't know what the risk is. Most of these things are startups. Even a project that's been replicated again, like a new cook stove project, same project, different context, real world. And so you start off with the best estimate of your curve on a continuous funding basis. But you need to know real time, how is that project progressing? So let's say this project is going to generate 1,000 carbon credits. So now you've made your investment based on the return that you're going to get 1,000 carbon credits. But in reality, the project's experiencing some difficulty. Okay, so now it looks like there's like an 80% chance that you get your 1,000 carbon credits. Now, are you going to put in the expected next payment, or are you going to say, you know what, I want to be paid more? Okay. So what it will do is automatically adjust the price according to the p-value. And so at the end of it, you get more or less dilution of your share. As I presume that you're not the only investor, so there'll be a bunch of investors. So let's say the best case scenario shares or like token supply for that bond is 1,000. But if it didn't do so well, it had to issue some more at a cheaper price. So now everyone gets diluted by, say, 10% or whatever. But then if it starts performing really well, then the price can go down and then you get back to 1,000. And so it's an adaptive financing mechanism.
That's amazing. I mean, this could be a really completely separate product, right?
It's exactly. So we've done that implementation with UBS on financing primary education tablet devices.
Wow.
Yeah. Done a lot. Okay, so then okay, and that's not all.
How many hundreds of you are there?
Oh no,
I mean,
it's been 10 years of building this, but also because we've built it in such a modular way, protocol based, and everything is very smartly designed. I think so. They're building blocks. And so it's modular, and it builds all these different applications. In terms of the AI, we have a Causal AI, which is white box explainable responsible AI. So there's 3 types of AI. There's correlation AI, which is most of what the world uses.
Yeah.
And what that's doing is classification mostly. So here's a picture, is this a cat, yes or no? And what that is doing with deep neural nets is it's extracting features and then creating a function curve, essentially, a function. and then it's set. Like after that, unless you retrain it, the function stays the same. And it's either yes, this is a cat, or no, it's a probability. Okay, but you can fall off the edge of that one, and it's only looking back. So the second type of AI is the one that we're all excited about now, which is generative AI. And what they can do is, with some degree of randomness, it can invent stuff. It can tell you what it's seen before, or it can give you some variations on that. We can get fooled into thinking that it's giving us advice that we should follow. It does give us some ideas, and it does give us some more information. Like, have you thought of this? Like what should I be thinking about when I'm going to marry this woman? Oh, well, you should think maybe about these 5 things. You go, oh, the 5th one I hadn't thought about before. So it's useful at giving you options and so on, but it doesn't tell you whether you should take option 5. And so the third type of AI is causal AI, which is a causal graph. So if this, then that. So going from inputs to process to outputs to outcomes, ultimately the impacts. And so it allows you to represent a decisioning system based on the information points that you have. Some of those information points are data intensive and may use correlation AI in terms of like time series analysis and so on. Others may be purely expert opinion, or even a political tyrant's opinion, or whatever, dictate. But you're explicit about it. You don't know why that person made that decision, but they make the decision, and they're one node in that decision tree, in the decision graph. And so you train the decision graph and you run different data through it to then optimize it based on the information you have available, calibrate it against the real world, and then it becomes executable. And so we bundle that up into an oracle, but a prediction oracle, not the type of blockchain oracles. Remember the Oracle of Delphi, she would give 2 types of advice. People would come in and say, I want to know the truth about X. And she would say, well, the Earth is flat. It's not a prediction, it was information.
Yeah.
So that's or maybe she didn't say it, maybe she said the Earth was round. But that's the oracles that mostly blockchain uses. It's trusted data sources. The other thing that the Oracle of Delphi would be asked is, am I going to have a good yield of my crops this year? Is my child going to be a boy child or a girl child? And the oracle would go divine away and say, okay, I predict this. And so prediction oracles are a whole new class of oracles that we're really sort of focused on, because we want to know what happened in the past and as a context for what should happen in the future, but we actually want to enable decisions going forward and optimization of those decisions to understand I've got decision A or B, or maybe C in the next step, and I learn as I go along, and then make the optimal decisions to achieve the outcome. And so we then can package that up into a service which is run as an oracle that you can request to look at your data, evaluate the data, and come back with a prediction function, which will either be proofing a claim, and it gets paid on a per service basis.
Okay.
So it can proof a claim, it can do personalization, it can do planning, it can do all these P functions. So there's 10 P functions. And so we've built an Oracle marketplace. It's called ImpactsAI, which enables you to build and deploy these oracles. And then the oracles can be employed to look at your data, to use your data, and provide the service.
Oh, wow.
I know that was a lot.
Yeah, it's a lot, but it's amazing. You were saying ImpactsAI.
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 Yeah. Do you have your computer? Maybe you can, I don't know if it's we just released it. It's still in beta, but we released it for the conference.
Okay.
I mean, we've been building these oracles, but now we have our platform for them, and I think it may be live. The guys have been working very hard in the past week. Yeah. we'll see. I don't know if the internet is so good here.
Wow. I mean, it's
That's why it's a new type of internet. You know, so when Tim Berners-Lee thought of the internet, it wasn't like an app. It's quite a big idea. It's protocols, it's infrastructure, it's applications, it's it's the whole shebang. Yeah. Hello.